Using any cross-sections of an area A can be used to determine the volume of a solid so long that the area A can be determined by some formula. What this means is we can find the volume of any irregular shape by using any cross-section we want. In example 6, a paperweight is made so that its base is the shape of the region between the x-axis and one arc of the curve y equals 2 sine of x. Each cross-section cut perpendicular to the x-axis is a semicircle whose diameter runs from the x-axis to the curve. Determine the volume. So the first thing we need to do is sketch the graph. So keep in mind that our x-axis is going to run this way, our y-axis is going to run this way, and our z-axis is going to run perpendicular to that. As we can see, the cross sections are semicircular regions, where this is the function f of x is equal to 2 sine of x. This means that the distance of any of these can be given by 2 sine of x. So if we look at this one right here, we see that this is also given by 2 sine of x for different x values. So if we look at this in 3D, we can see that if we were to break this up into many cross sections, we would get a bunch of semicircles, and if we graph them all, we get this weird 3D shape. So now we're going to look at the area of a circle, and we know the area of a circle is pi r squared, so the area of a semicircle is 1/2 pi r squared. So what we need to do is find the radius for each cross section. Well, we know the diameter is 2 sine of x, and we know that radius is 1/2 the diameter. So the radius is 1/2 times 2 sine of x. So the radius is sine of x. So then the area of each cross section is going to be, area is 1/2 pi r squared. So then the area is 1/2 times pi sine of x squared. So then when we determine our limits of integration, we're going to look back at the graph, and we're going to see that we go from 0 to pi, so those are our limits. And now to find the volume, all we have to do is integrate. So we set it up, and it's going to be from 0 to pi of pi over 2 sine squared of x dx. So I'm going to rewrite this as pi over 2 from 0 to pi sine squared of x dx. And to integrate sine squared, we're going to need a trig identity. So we have that cosine of 2 theta is equal to 1 minus sine squared of theta. So rearranging that, we get 2 sine squared of theta is equal to 1 minus cosine 2 theta. And so sine squared of theta is equal to 1/2 1 minus cosine 2 theta. So this is going to change our integral to pi over 2 from 0 to pi of 1/2 1 minus cosine 2 theta, or 2x dx. Alright, so now it's all left to do is integrate. So this becomes pi over 4 from 0 to pi 1 minus cosine 2x dx. So we get that this is 2.467 units cubed. So now on your own, I want you to try this problem. The base of the solid is the region between y equals the square root of sine of x and the x-axis on the interval 0 to pi. The cross sections perpendicular to the x-axis are equilateral triangles. So the first step of this is to graph it out and try to find the area of a cross section and then integrate. So on your own, give that a shot. Okay, so step 1 is to graph it. So to do that, we're going to use the square root of sine of x. And if you don't know what that looks like, go ahead and just graph it on your calculator. So it looks something like that. And then what we do is we pick any random point on the x-axis and connect it to the function. And using these points, we're going to make our cross-section, which in this case is an equilateral triangle, where the base of this is square root the sine of x. So in 3 dimensions, it'll look something like this, where each of these is represented by the square root of sine of x. So our base shape is an equilateral triangle. And so what we're going to do to find the volume or area of that is we're going to break this into a 30, 60, 90 triangle. And since the whole base is the square root of sine of x, half the base is the square root of sine of x divided by 2. Since this is the square root of sine of x over 2, this is going to be radical 3 times the square root of sine of x over 2. And so now what we need to do is find the area. And so we know area is equal to 1/2 base times height. So this is going to be area of x is 1/2. Our base is the square root of sine of x. And our height is going to be radical 3 over 2 times the square root of sine of x. So simplifying that, we get the area of each cross section is radical 3 over 4 times sine of x. So the area of each cross section is the square root of 3 over 4 times sine of x. So to determine volume, all we have to do is integrate. So volume of x is the integral from 0 to pi of the square root of 3 over 4 sine of x dx. So when we integrate, we're going to go ahead and pull out the constant. You get square root of 3 over 4, the integral from 0 to pi of sine of x dx. And now that's all that's left to do is just integrate. So here we go. And so we get radical 3 over 2 units cubed.